All right, hi everyone. Thanks for coming today. I hope you're having a great time at DockerCon. Please welcome Mohammed Abulait. He's Deputy CTO at XHub. He's been there for 6 years, and he is designing, architecting, and building efficient IT solutions at scale. Mohammed has been a very early Docker adapter, putting his job on the line all the way back in 2014 by pushing it to use in production when it wasn't even officially released yet. He's going to tell us today about the best practices for using Java in containers. And you can reach out to him on Twitter at Laytoon. That's Laytoun. All right. Thank you, everyone, and take it away. Thank you.
Thank you. Hello, everyone. Thanks for joining me for a discussion about Docker containers and Java and the things that we should know. Before starting and jumping into our presentation, just a quick introduction. I'm Mohammed. I work for a DevOps company in Morocco called XHub. And if you want to have a chat or maybe a drink, the easiest way to find me is in Twitter, and my Twitter handle is Laytoun. So my talk today will highlight the story of a Java developer called Pharaoh. And Pharaoh has been a Java developer for a couple of years now. And he started learning a lot about this cool new technology, which is containers. And I want to start learning it and play with it a little bit. So our talk today will highlight his journey, starting by somehow the philosophical question. Is it a good idea actually to put a Java application or JVM application inside a container? We will discuss afterward how to create effective images for our Java applications. We will see the tools and libraries that help us to get up and running quickly while using containers. We will see the things that we should know and the things that we should avoid while deploying our containers into production. And finally, we will discuss all the features that has been added to Java to make it more container aware. So, as you know, containers are nowadays everywhere, and they are used for a wide range of applications, from fast serverless applications to huge monolith applications, and that's because they offer this ease of deployment and backed by this huge ecosystem that offer many tools and softwares that help managing containers and making it easier. But one great feature of using containers is this a dense backend which offer resources optimization. And the technology behind this feature, the lightweight isolation of containers, are two things, are namespaces and cgroups. And very briefly, namespaces are used for providing isolated view on the system. So each process will have its own view on different namespaces like user ID, process ID, and so on. Cgroups, on the other hand, are used to provide limiting and measuring for the resources that a process can use. So given a process, well, what we can see is the resources that you can use, like memory, CPU, block I/O, network I/O, and so on. So in cgroups, each subsystem form a tree structure or a hierarchy of nodes, and each node and each process belongs to one node and one node only in each hierarchy. So given a process, it will belong to one node for CPU, one node for block I/O, one node for memory, and so on. So if you think about it, initially, when the system boots, there is only one node, one big node, and the initial processes belong to this node. So even if you are not using containers yet, you are just using one big container with no limitation and no constraint. So Pharaoh then asked himself, is it a good idea to actually put a Java application inside a container? And especially that the Java is hardware and OS agnostic, and it's runtime adaptive, which means that the Java and the JVM will try to adapt itself on the execution environment to ensure the best performance for its execution. But Pharaoh, however, decided to give it a try, and after reading a couple of tutorials, he came up with this DockerFile, he built it, he ran it, and all working good. But Pharaoh asked himself, what I actually need from a container? And the answer is basically three things. I need a good base image that contains my runtime dependencies. I need also my image to have the smaller size possible. And I need my container to have a fast startup. So first things first, and when we talk about a good base image, in the context of Java, we talk about the Java runtime. And there were a huge discussion lately about the Java and its future, especially after the new licensing model from Oracle and and the new release cadence that we are not familiar with as Java developers. But however, Java is still free, and there are many providers that offer it for free, like even Amazon is now offering its own OpenJDK build, which is Amazon Corito. And if you need support, there are many providers that are offering that as well. The next thing we need from our container is to have a smaller size. And for that, many techniques exist in both the Java side and the Docker side that helps to achieve that. And from the Java side, there is this feature introduced back in Java 9, which is Java modularity, which enables us to tailor the JVM and select only the modules that we need. And we can also make our own GERE, we can make our own runtime, custom runtime, putting the JVM in a strict diet. Practices like code refactoring and code reviews also helps to reduce the complex logic, reduce the overall lines of code, and also detect if we are using a whole dependency for a small utility function. And talking about dependencies, there are tools in the JDK itself, like GDEPs, or tools that are available in Maven and Gradle that help to detect what dependencies are we effectively using and what are those zombie dependencies that are just sitting there in runtime. And there are many plugins that help us get rid of those dependencies. From the Docker side, think of using a smaller base image. And the smaller your base image is, the smaller your final image will be. Understanding also the principles of layers and caching of Docker helps to generate a smaller image. And generally speaking, it is a good idea to combine the related comments in your Docker file and separate the unrelated comments in it, cleaning up right away. And it is a common practice while working with DockerFile to download an archive, extract it, do some modification with the files, and then forgot to remove this archive. So removing this kind of files, as well as some caching directories and some log directories, help to reduce the image size using Docker ignore. And depending on the application, we may want to ignore some files and directories like the log files and temporary files. And this helps to reduce the image size. And one nice side effect of using Docker ignore is that it helps to speed up the build process, since the context, which has the files that need to be sent from the Docker CLI to the Docker daemon are fewer. Using also multi-stage builds helps, and multi-stage builds helps to separate our build process or our build stage or stages from our production stage. And this helps to keep our production image clean without the unnecessary build dependencies using Docker Squash utility. And Docker Squash is basically a utility that squash the Docker layers image in order to generate a new image with fewer layers. And there is even an experimental option in the Docker build command, which is that squash, which does exactly the same thing. And when we mentioned using a small base image, one lightweight Linux distribution worth mentioning here is Alpine. And Alpine is a lightweight Linux distribution. Its size is under 5 megs, and it's based on muscle libc and busybox. And very briefly, busybox combines tiny versions of common Unix utilities into a single executable. And muscle libc is an implementation of libc as the standard C library. And this is basically the standardized interface between the kernel and the user net. One big difference between Alpine and other common Linux distribution is those Linux distributions are not using muscle. They are using instead glibc. And that means that a code that is a C++ code that is compiled with glibc will not work on muscle. And you may be wondering why we are talking about C and C++ code in a Java session. And that's because we, as Java developer, we are using a software that is written in C++ to do a lot of its code, a lot of its work, and it's the JVM. So in order to ensure a transparent run of the JVM on Alpine, some code modification needs to be made on the JVM itself. And luckily, such project exists, and it's called Project Portola, and you can start contributing to it, and you can even start trying it as part of the early access of Java 13. And you may find on Docker Hub and especially the adopt OpenJDK repository, some Java images that are based on Alpine. And what these guys are basically doing, they are just adding glibc Alpine package on top of Alpine. As far as I know, they are not using Project Portola on any muscle port on the JVM. And this slide gives a quick comparison of some Java images that we can find on Docker Hub and on the internet, and it shows that the smaller your base image, the smaller your over image will be. And the winner here is by far the OpenJDK JArray 8 image, and followed by two other Java images of Java 8 and Java 11 coming from Google Cloud Registry. And those images are part of a Google project called Distroless Container Images. And this project aims to create images that contain only the application and its runtime dependencies, restricting what's inside the application to just what the application needs to perform its function. Those images are built using Google Bazel tool, and this project supports multiple languages, including Java, of course. And one nice thing about this project is the base image that these guys are using, which is a lightweight Linux distribution and glibc based, and its size is almost 8 MB, which can be considered as a nice alternative for Alpine. And someone should ask, why should I care about making my image smaller? And the quick answer is the smaller is better, and the long answer is each time you are pulling or pushing your image, you are incurring expenses on terms of data cost and time. Everything in your container is something that the provenance need to be tracked and need to be scanned for vulnerabilities. And finally, the smaller your image, the fewer components it has, the smaller the surface attack. And finally, and the third thing we need from our container is to have a fast startup. And Java, as we may know, has relatively this slow startup. And the Java community knows that, and they were making a huge effort to improve that. And the easiest way to benefit from all this effort is to start using Java 11. Other techniques can be used to improve the startup time for our Java applications, and let's see them in action. I don't know if you can see the slide. It is clear? Okay, so my project here is just simple niche applications that whenever it receives a request, it prints hello world. And to measure the startup time of application, once the server starts, I exit the application. I'm also using a script to benchmark to measure the startup time, which is the time that the container took from start to finish, and also to measure the size of our image. This project is also multi-branch, and it's multi-branch, and each branch represents a feature that we can use starting from the master image. And here basically I'm just running my application with Java 11 without any modification. So if we go to another branch, which is CDC, for example, which stands for class data sharing. And class data sharing, why we need it? The JVM does a lot of stuff, a lot of preparatory stuff to execute the code. So given a class name, it looks for this class name in the Java, it loads it, it verifies the bytecodes, and then puts it in an internal data structure. And this took a lot of time, especially if you think the JVM needs to load hundreds and thousands of files during its startup. So the idea here is to dump this data once, archive it, and then use it for future launches, and share it between multiple JVM instances and multiple containers. And as you can see here, I'm running the application and then generating a dump and specifying where this dump should be saved in an archive. And in my production image, my final image, I'm telling the JVM to enable the sharing and then start using this archive file. Other technique can help us, which is ahead-of-time compilation, which is really similar to just-in-time compilation, but it is used to improve the startup time. And as just-in-time compilation compile the code that the JVM execute into native code to improve its performance, ahead-of-time compilations let us compile some code that we need during startup time to native code, so the JVM can load faster. And in order to do that, we need to provide the JVM with a file containing the methods and the classes that we want to compile. And then in the build stage, we use the GAUTC command, which stands for Java AUT compilation command, to build, to generate the native file. And then we tell the JVM to start up and look for, if it needs a class or a method, it loads from this native file instead of compiling it during startup. Another technique, and this time is, I mentioned it for improving my, to make my image smaller, it's Java modularity. And here I'm using glink command and selecting only the modules that I need for my application to run, and generating also a custom GRE. And in the build image, what I'm doing, I'm not using the full GDK, but instead only the custom GDK, and then running my application with it. And if we go back to our master class and run the master branch story and run our project, I'm not going to run it because it takes some time. But here are the results that we have. And we can see that if we compare the plain startup time compared to AUT and CDC, we see a little improvement. And if we compare it to modularity, we see that the size of our image is smaller. Finally, one nice project from Oracle Labs worth mentioning is GraalVM. And GraalVM is a universal virtual machine for many languages, such as JavaScript and Ruby and many JVM languages, of course. And what this project lets us do, and what excites people about this project, is a sub-project called SustrainVM, which compiles our Java application and our JVM applications into native code and generate a static binary. So we don't need anymore to have a JVM to run our Java applications. Instead, we need only, once we generate the binary, and we use a native image command from Graal to generate it. Once we generate the binary, we can simply execute it even without the JVM. And if we see the results of the benchmark here, we can see that the startup time is a lot more smaller and our image size is a lot more. The startup time is faster and our image size is smaller. And if we go back to our slide, containers changed the way we develop, architect, and deploy our applications to become the executables of the cloud. However, Furu thinks that containers added a new level of abstractions, and was wondering if we can use the same good old tools that we are all familiar with as Java developers in Maven and Gradle to generate our Java archive, and instead generate this new unit of deployment, which is containers. And luckily and fortunately, such plugins exist in both Maven and Gradle. And the easiest way to achieve that and to integrate Docker built into Maven lifecycle is to use Maven exec plugin. But this solution, however, is not so elegant. Other more sophisticated and more robust plugin exists, such as Spotify, DockerFile Maven plugin from Spotify, and Fabric 8 Maven plugin from Red Hat. Other plugins exist in Gradle as well, and those plugins enable us to do a lot of stuff like building our Docker images, pushing it into production, and starting containers, stopping containers, and a lot of stuff. One other project worth mentioning here is Jib. And Jib is a Google project, and it's a Java plugin that supports both Maven and Gradle, and it helps us to build our images and push them to remote registries without having a Docker file and without even having a Docker installed in our machine. So what Jib basically does is it's something similar to what's inside this Docker file, and it splits our application into multiple layers, putting the files and layers that are less likely to change on the top, and the files that are more likely to change, which is our code files and our class files on the bottom. And that helps to speed up the build process, especially on incremental builds, and helps to ensure producibility, since if the code doesn't change and if our resources file and dependencies file doesn't change, the generated image will be the same. Another important topic in software engineering in general and while working with containers is versioning. And there are many techniques that help us to version and tag our images. And nothing stops you from combining those techniques. But if like one nice achievement from versioning our images, it's that it helps us to track at any moment of history how our application looked and how our container behaved. Another important topic here is security, and this needs a session on its own. And I believe there are many great sessions here on DockerCon about security and containers. But my goal here is just to give some bullet points, some recommendation that we need to keep in mind while working with containers. And the first thing is knowing what's inside your container. Especially if we are working with third-party containers, we need to make sure that those containers are not downloading anything during runtime. We need also to make sure that our application is secure by running it against SaaS tools and vulnerability scanning tools. We can run, and we should run our final image, our generated image for vulnerabilities, and for that, many scanning tools exist in the market. And there are some that are free, like Aqua Microscanner. If you are not using Docker Control Trust yet, please start doing it. And when using it, the Docker engine, when you try to push the image, Docker engine will automatically sign your image with your private key. And when a later user wants to pull the image, the Docker engine will automatically verify this image using your public key for integrity, authenticity, and a lot of great stuff. Adhering to least privilege principle is important. And in the context of containers, that means that we need to make sure that each process and each container is running with the minimum set of access rights and resources to perform its function. And many steps can be followed to achieve that, like making sure that each process in our container are not running as root. So even if an attacker succeeds to exploit a vulnerability, that does not give him a root access. Running our file system as read-only, so that an attacker cannot modify data and save malicious scripts. And finally, limiting the resources that a container can use helps to avoid some attacks like DOS attacks. And as mentioned previously, having a minimal container OS helps to reduce the service attack. And an important thing is having monitoring and auditing tools in place helps to detect unusual behavior and trigger alerts if needed. Another integral part of software engineering is testing. And testing helps to verify that the code we write works according to specification. But having and creating this real isolated testing is hard, especially that our application needs to communicate with databases, need to communicate with other services through HTTP APIs or through brokers, need to send emails, and thus it needs SMTP server, and so on and so on and so on. Containers help it to make this process easier, and one library worth mentioning here is test containers. And this library basically is a Java library. It integrates easily with a lot of JVM testing frameworks, and it has a lot of features, a lot of nice features actually, like port randomization. It provides throwaway instances of common databases, and it's clean up automatically the containers after the JVM shutdown. So with that, Furo seems convinced and happy and confident to deploy its application into production after it works perfectly on his local machine in dev environment and staging environment. And let's see this in action. So first application is simply a pit clinic Spring Boot based application, and the Docker file it runs with is very simple, and it's based on Java 8 build number 121, and we start the application with two options. We want the JVM print the options that is used to start, and we want to track the native memory that the application is using. So let's run the application, and I've already created the image, and in the first we will run it without any constraint and any limitation. So the application here, as you can see, it's specified the maximum heap size that you can use to almost 2 gigs. And this is a nice feature of the GVM, which is the GVM ergonomics, which let us, if no tuner parameters are passed to the GVM will try to set these parameters by itself. And one of those parameters is the maximum heap size and the initial heap size. And it does that by collecting a number of information from the underlying host, like the memory, the number of CPU, and many other things. So here, I'm telling my Docker desktop to use up to 8 memory for containers. And the 1/4, which is the maximum heap size that the GVM sets by default, is 2 gigs. And the initial heap size that the GVM sets by default is 1/64. And as you can see, the application started nicely without any errors. And if we try to see it, it's simply a simple Java application running correctly without any errors. I generate an error here, so yeah. So how about if we try to constrain, like to run the GVM with fewer memory, and let's see how the GVM will behave. So let's try to run the GVM with 200 megs, and let's give it a name. Surprisingly, the GVM still thinks it has 2 gigs. It has 8 megs of memory and sets the maximum heap size as 2 gigs without taking into consideration the limitation that we set here. And what will happen is that the application will not run, because the GVM is not aware of the limitation, that the memory limitation that we provided. And if we check the inspects command, we can see that our application, our container, received an out of memory kill signal, and that's because it used more than its memory. And we are Java developer, and we have like an out of memory exception. What we do is we add more memory. So let's try to add more memory. And let's make it 500 now. So the GVM is still not container aware, but how many of you think that the application will actually start? 1. How many of you think it will not start? The application surprisingly starts and succeeded to start in my machine, but it will not happen in a production server. So let's try to generate some load and on our application. The application, however, is a bit slow, and it struggles to serve all these requests coming to the application, but it manages somehow to stay alive. And come on. And to have a look and to understand how the GVM uses its memory, we can use a nice tool, a nice command from the GDK, which is GC command. And G command, what it does basically, it sends diagnostic requests to the GVM about many things. And what we're using here, and we are just telling the GVM, I don't know if it's clear, I need to maybe. And we are telling the GVM to send us information about the memory it is using, and we are specifying the unit to megabytes. And what we see here, surprisingly, is the GVM is using more than 1 gigs. Even if we're specified only, it can use up to 500 megs. And only the heap size is using around 800 megs. And if we see this fact and think about, let's stop the application and think about the slowness that we had the application while serving its request, one thing and one answer comes to mind is the application is actually swapping. So to prove that, let's try to disable swap. And we do that by actually specifying the same size as the memory. And generally we do. Okay, swap. I'm sorry. Come on. Swap. And we do that, and we disable swap generally on the OS level. But let's have a question. Let's have a quick poll. How many of you think, however, this application now will start? 1, 2. How many of you think that 3? How many of you think the application will not start? So many. Who doesn't give anything? So the application effectively does not start. And Furu start to be a little bit pissed and start to look for answer for why its application that was working perfectly in its local machine and its dev environment and staging environment does not work in production. And the first part of the answer is from history, actually. So the containerization movement started back in 2000, and when Docker appeared in 2013, the containerization movement exploded in popularity. However, Java was there since 1997. And when Docker first appeared in 2013, Java 7 was already out, and the work on Java 8 already started, which explains a little bit why the JVM is not container aware. Second part of the question is the JVM ergonomics, and as I mentioned during the demo, the JVM will try to adjust itself to ensure the best performance on the execution environment, and it does that by collecting a number of information from the underlying host. And if the JVM fails to get the correct value of this information, or it gets it from the wrong place, this nice feature of the JVM will become a nightmare. And as we see, the first example is the memory, but the same thing can happen to the CPU, the number of processes. If the JVM fails to get the correct number of processes, this will impact its internal thread pool. It will impact Java popular APIs, such as the fork join API and the streaming API, and it will impact many popular Java software, such as Elasticsearch and Tomcat. So the issue is now known, and the Java community has been working hard to make the JVM more container aware. However, and unfortunately, if you are using like Java build number 121 as Furu, there is no solution, and you need to specify those values by yourself. Or you can use a nice script from the FabricH community, and what they are doing, they are collecting the limitation from C groups and calculate the values that the JVM needs, and they pass it to the JVM as parameters. The first results of this effort to make the JVM more container aware started to appear with Java 9 with some options, but unfortunately some of the options are experimental, and good luck convincing your manager to use an experimental option in production. A huge effort has been made in Java 10 with more options that allows more fine-grained control over the memory that the JVM can use, and such as the heap size. And a new formula was introduced to calculate the total number of CPU, and this formula is calculated based on the minimum number of CPU shares divided by 1024, and the CPU quota. And we can even specify the total number of processes that the JVM can use by using the active processor count. The effort continues in Java 11 with the introduction of new options, which is a new option which is preferred container quota for CPU count. And this option was introduced to fix an underutilization issue that appeared with Kubernetes with the formula that was introduced back in Java 10. And other great things have been introduced, like container metrics and many other things. So when running a Java application in production, we need to keep an eye on how the JVM is actually behaving and how it's used its memory and stuff like that. Many tools can help us toward this journey, and many tools are provided in the JDK itself and by third-party providers. And when we run our Java application inside the container, we need to keep an eye on how our container is behaving. For that, there are tools There are free tools, and there are many commercial tools that you can use to achieve that. So to wrap it up, is it a good idea to put a Java container, a Java application inside a container? Sorry, yes, but there is some limitation. And the easiest way to achieve that is to start using Java 11, since it contains a lot of features that makes the JVM more container aware. Keep in mind that Java has a rich and strong community and a rich ecosystem, and it offers many tools and libraries that help us getting up and running with containers technology, and there are many tools that helps to make our Java applications more cloud ready. And with that, thank you. I'm ready to take your question, and if you have more in-depth question, join me to my hardware track, which is an hour from now. Thank you.
All right, thank you very much, Mohammed. Anyone with any questions?
Well, it's not a question, but can you please show your GitHub again, the address of GitHub with sources?
Yeah, I'll publish him in Twitter, and okay. They are, so he was asking about the GitHub link for the demo, and it's this one, it's here. So, and I'll mention it in my Twitter account.
Any other question? Oh.
So you mentioned to start with Java 11. Has there been any improvements with Java 12?
Yeah, not many. Like all the features that has been added to Java 11 are the more advanced features. There are some, but just tweaks. And with the new release cadence, which is 6 months, so Java 11 has by far the most features that make the JVM more container aware. And the Java 11 it's the LTS version, so you don't want to use a short with Java 12 in your production environment. So if you're gonna use Java in production, start with Java 11 or wait for the next LTS release.
So I'm porting some legacy software, as in Java 1.3 and Java 1.4.2. And what if you can only get something as far as 1.6? How does that run in a container?
The JVM, obviously. So he was asking if what the tweaks and the hacks that we can make to the JVM if we're using like Java up to 1.6. And unfortunately, the JVM is still not container aware. And for that, you need to pass those parameters, like setting the parameters that the JVM needs, like the XMS, XMX, the total heap size and the initial heap size, the total number of CPU and stuff. And you can use even the scripts that the Fabric 8 community came up with that helps to get the limitation from the C groups and inject it while starting up the JVM. So 2 solutions, explicitly mentioning those parameters or using a similar script like the Fabric 8 community did. This one. And the link is on the slide. Perfect.
All right, any other question? All right, thank you very much, everyone. Thank you, Mohammed.
Thank you. Thank you.
Now it's time for lunch, and breakout session will resume at 2 p.m., I think. Thank you.